Welcome everyone to the Fundamental Theorem of Calculus with Mr. Walton. Our first example of the day is given. dy dx is what we're looking for. As we look at this problem, please remember that dy dx is equal to dy over du times du dx. And the reason for this is we want to use u substitution, u being equal to 5x minus 1. We also are going to find du dx so that we know that it's equal to 5 by taking the derivative of 5x minus 1. By doing so, we can rewrite our function in terms of the derivative dy dx by taking the derivative of the integral Please remember that when we do this, taking the derivative of the integral, that our value for the number will go away, and we will have the tangent of u squared times du dx. Then we're going to plug in for our u and our du dx. We're going to find that it's the tangent of 5x minus 1 squared times 5. And finally, that allows us to expand the binomial for a final answer of 5 tangent of 25x squared minus 10x plus 1. Moving on to our next example. Find dy dx if y is equal to the integral from 3x to x cubed of the quantity 1 over 3 minus 2e to the t power dt. Put a reminder here. First, let's separate the integral. So it's going to be a lot easier for us to find dy dx if we separate the derivative into two integrals, 0 to x cubed Please remember, this is important right here. We have flipped this because instead of going from 3x to 0, we want to go from 0 to 3x, which means we need to take the negative of that. To continue, let's use some u substitution. If we let u equal x cubed, then du dx is equal to 3x squared. On the opposite side, if we let u equal 3x, then du dx is equal to 3. This allows us to solve so that we have the integral from 0 to u And now it gets a little confusing with the u, so my suggestion is you may want to change this to w, just so we have slight difference, and then you can tell the two integrals apart from one another. We find that we're going to get 1 over our function to the u power times du dx minus our function again, but this time it's going to be te to the w times dw dx. If we substitute in appropriately, we would have dy dx equal to 3x squared over 3 minus 2e to the x cubed minus 3 over 3 minus 2e to the 3x. Since we do not have any common terms, this will be our final answer.